Hello, everyone. A very welcome to you. My name is Amit Kumar, and I will be your discussion partner for this session today. So we have a 2 hours webinar on DevOps. Yeah. So in these 2 hours, I'm going to talk about basics of DevOps. What is DevOps? How did it came into being? And what are various tools and technologies and philosophies that we talk about when we talk about DevOps? All right. By the way, my screen is full screen already. If you see a window as a screen in your device, then please make it full screen from your end. From my end, it is full screen window. Okay. Okay. So 2 hours for DevOps. A little bit about me. I have 16 years of experience in the industry. I currently work as principal architect DevOps in my organization, and my responsibility includes the DevOps transformation for many of uh, our teams who are doing rapid development of web applications or standard applications, firmwares, different kinds of applications, right? So I've been in the industry for 16 years, and I have worked on the entire DevOps uh, landscape. So I have worked a lot on version control systems. I've worked a lot on CI and CD systems, and also deployment platforms and technologies. Right. So I have worked on the complete length and breadth of uh, DevOps. Right. So today, 2 hours, we will discuss about DevOps, and at the end of the 2 hours, you will get some understanding of what is DevOps, how DevOps works, and what you should do if you want to get into the DevOps field, and if you want to make a career in DevOps. Okay. So there are many people who are complaining about either audio not being available or screen not being available. What about others? Do you guys see the screen and hear me clearly? Okay, so almost all of you can see the screen and hear me as well. Then it's good. Looks like then the issue may be at those participants' ends. Okay, cool. Thank you. Thank you for the feedback. So yeah, 2 hours for DevOps, and at the end you should be able to understand what is DevOps and how do we work with DevOps. All right. So let's start. First of all, before learning about DevOps, let's learn about the traditional way of software development, which is waterfall and agile. These are still pretty popular development technologies, and they're still relevant and are being used in the industry. Okay, so let's talk about waterfall, then we'll talk about agile, and then we will see why DevOps came in and what problems does DevOps solve. Okay, so let's say you are following the waterfall software development methodology, and you begin your initial discussion with your customer on at, let's say, T0 time, right? Maybe somewhere in the past you started discussions with your customer on what they want. Mm. And during the initial discussions, they will give you complete information about their expectation from the product, right? So you will have a set of requirements from your customer. right? So you gather all your requirements from your customer. Maybe you take 2 months to do it. You have repeated sessions with the customer to finally freeze the requirements. At the end of this requirements gathering stage, you have an agreement, right? Agreement on what is the scope of the project, what is the cost of the project, and what is the timeline of the project, right? You define this. Then after requirements, you start implementing it, right? So first thing that you do is design it, design the product. Maybe it takes another 2 months to design the product, right? So you started at T0, and after 2 months you reached at T2, where you have your requirements done. Then at T4 you have your design done, and after that you get into the longest phase of the implementation, right? So you do your implementation here. Okay, and in the implementation you do iterations of coding and then testing and then coding and then testing. So you do code, then you test it, you find problems, then you fix those, you test it, you find problems, then you fix those. You go on in a cycle like that. Yeah. And at the end, when your test results come back as okay, that's when your product is ready. And let's say that happens after 4 months. So your product is ready, and then you do a release, right? You do a release. Maybe you have to just give your customer the binary, or you deploy it, or whatever is part of the release. Okay, and then at the end you can continue doing the maintenance. Depends on what agreement you had with your customer, right? So this is pretty standard waterfall way of working. Hmm? So you start with requirements, then design, and then implementation, and then deployment. Okay. The problem with this approach is that the customer who has given you the project and who is waiting for his product to be used does not see the product unless we release to him, till the time we release to him. So only at the time of release the customer gets a look at their product, and then by that time things could have been same and the customer would be happy with the product. But during or with the dynamic uh, markets that we have now, the customer requirement may have changed, right? Maybe in the beginning customer said that I want a website which is red in color and which is integrated with Google Plus. But by the end, after the 9 months, when the customer receives, Google Plus has become irrelevant. So they don't want Google Plus anymore. They want integration with Google or Apple ID or Facebook or whatever. They don't want red color website. They want blue. Yeah, because market has shifted towards blue. So although the product was developed according to the requirements, but from the customer end, these old requirements do not make sense anymore, right? With waterfall, it's very difficult to change requirements in between. Customer cannot just barge in after 5 months of work and say that change the requirement and make it from red to green or red to blue and integrate with Google Plus or Facebook or whatever, right? So the requirements changing is very difficult in waterfall. So there is very less flexibility in waterfall. Once requirements are frozen, you cannot change them. Once design is done, you cannot change them. When implementation is done and it is released, you cannot do anything about what you implemented, right? So because of this rigidity, there was a new software development methodology introduced called Agile, right? In Agile, you don't commit on the timeline of the product. What you say is that, okay, customer, let's sit together and I want you to give me all your requirements. So what are your requirements? You list them down. Okay, so requirements could be initially that the website should be red in color. It should integrate with Google Plus. There should be a login page. There should be a shopping cart page. There should be account management page. There should be a orders history page. Yeah, many things. These are the requirements of the customer. And then what you'd say is, as a development team, you say that, all right, I am going to work for a small duration of time, a sprint of time. For example, I will work for 2 weeks with my team. Give me your top three requirements. I will take those requirements and try to get them delivered for you. So customers will say, all right, my first basic requirement is that I should have a login page. So this is my first requirement. Then I should have a shopping cart. This is my second requirement. And I should have an order page. This is my third requirement. These are the top priority requirements. So the development team will take these three requirements and then start doing development. So they will plan, they will design, yeah, they will code, they will test, they will build, and at the end of 2 weeks they will release. Right? So they will work for two weeks, get the requirements sufficient for 2 weeks, and then make a release. And then when they release, they do a demonstration to the customer. And then after every sprint of work, the customer can say, all right, this is going in good direction. This is exactly what I wanted. And thank you. Let's work on the next features. So you then work on 2 more weeks and you take next features into your sprint. You plan those, you design those, and whatever you do, and then make a release and a demo to customer. So during the sprint, customer cannot change anything. Whatever requirements you have picked up, they will be worked on. But customer can always refine the remaining requirements and prioritize the remaining requirements. So customer can say, all right, in the next sprint, instead of whatever is done for a website with the red color, make it green. Yeah, this is my requirement for the next sprint. Develop the website in green or in blue. Yeah, implement Facebook integration. So implement that. So it's the full control of the application is on with the customer. The customer can decide what happens in the application, what is deployed, what is delivered. Okay, so here you can see we are making many frequent releases, right? In waterfall, we just release everything at once as a single package, but in agile we release every end of every sprint. So very, very frequently. Here you can see in this example, we are releasing every 2 weeks. Okay, this is how agile works. Now, there is a problem with this. The problem is, although this works fine, but for example, let's say we picked up three features for this sprint to be worked on. Feature number one was done at this point of time. Feature number two was done at this point of time. And feature number three was done at this point of time. The release to the customer happened at this point of time when the feature three was implemented. So feature one was implemented at the end of in the middle of first week. Feature two was implemented at the end of the first week, and feature three was implemented at the end of the second week. But still, the feature one and feature two were just lying there waiting for a release. Okay, so this is because we have planned our release like that. We are doing event based releases, right? We are doing event based release. What generally DevOps suggests is we should do value based release. What does that mean? That means as and when we see a value implemented on customer's product, we should release it. So feature 1 adds sufficient value here. Then there should be a release at this time. They should be released at the time when feature 2 is implemented. They should be released at feature 3 implementation. So instead of having one release at the end of the sprint, we should have frequent releases whenever our features are developed. Okay, this is called as DevOps. So DevOps is kind of a next iteration of Agile, where instead of releasing your product at the end of the sprint, we release them whenever they are implemented. Okay, so if you have to do a comparison in case of waterfall, yeah, you have this project timeline and you release at the end, almost at the end of the project timeline. If you talk about Agile, if this is the project timeline, then you release at regular cadence or regular frequency, right? But if you talk about DevOps, and this is the project timeline, then you release whenever enough value is accumulated, right? So there is no fixed schedule. Whenever something is implemented, you release it. Okay, this is called DevOps, right? Now, why is it called DevOps? Why not something else? Okay, let's talk about that as well. So when we say DevOps and when we want to make these frequent releases, for example, feature 1 is implemented and the development team has taken the feature 1 and then is trying to make a release here, what their development team is going to do is they are going to create a deployable package. Yeah, whatever your exe, your war, your jar, or whatever is supposed to be delivered to the customer. And to deploy this, we have a specialized team called as operations team. So you have your dev team, which is making this product, and the operations team, whose responsibility is to deploy this product. So here we are developing, and in the operations side, we are deploying or maintaining, yeah, operating, whatever you call it, right? So these are two teams, development team and operations team. The development team makes the product and gives it over to operations team to deploy, right? Now, with the DevOps, you can see there are a lot of changes happening. Every week or two times every week, there could be a release happening. And because the release is happening, because there is so much change in the code base, then there could be a lot of changes in the required underlying infrastructure for the application to run also. For example, let's say at this point of time, guys, can you please stop spamming the chat window with SonarQube and Ansible? I'm not sure what is driving this, uh, but yeah, we will come to that. Let me explain this, and then I will take that as well. Okay. So getting back here, so you can see there are a lot of releases made in DevOps, right? A lot of frequent releases. Maybe up to this release, we were using Java 1.8 for our application development. So operations team had infrastructure configured accordingly with Java 1.8, right? But then we realized that we need to add more features to our application, and more features are available in Java 1.11. So at this point of time, we adopted Java 1.11, for example. And then when these releases started go out, they all were developed in Java 1.11, but the operations team was still on 1.8, right? And these deployments will fail, right? So when such deployments fail, there is always a question of whose responsibility is this. Is this the operations responsibility? Is this the development team's responsibility to ensure that the application is deployed on the correct infrastructure? The development team will say, it's my responsibility to make the change to the product. I want to bring in the change because we are making something new. The infrastructure team or the operations team's point is that we do not change much in our infrastructure because we want stability. My salary depends on how much stable I can keep this infrastructure, right? So both of the teams are working towards the same goal, but their incentives are different. The operations team incentive is in keeping the infrastructure up and stable. The operations or the development team's incentive is in keeping the product changing frequently so that the application is developed according to the customer. Yeah. So the idea is that we bring these dev teams and ops teams together. How do we bring them together? Well, we make the dev teams also perform some of the operations tasks which are relevant to their product, right? So the development team also performs some operations tasks. For example, upgrading the Java version or installing some other tools required or making the infrastructure ready for their next choice of technology. All those can be performed by the developers themselves. And that's why such a setup is called as DevOps. Okay. So with DevOps, the development team performs a lot of operations tasks also, and also it enables the teams to make very frequent releases. As and when code is implemented, it is released. Okay. Questions on DevOps. So I see a question from Apurv. When we say DevOps releases more frequently than Agile, is the release happening in between the sprints? So when you have DevOps, you do not have sprints. Okay, you are just churning out all the features and releasing them whenever they are ready. Okay, so there are a lot of points here from Vijay, Subrat, Abhay, and Azad that agenda covers static code analysis, configuration management using Ansible. So is this a question or is it a statement? Yeah, what is the expectation here? There should be some ETA for each release. Yeah, so now we are getting into project management territory, right? Obviously, there will be an ETA, there will be high level agreements that we will make releases. Our project will be completed by this time, for sure, yes. But those intermittent releases may not be uh, uh, may not be governed by those agreements, right? Also, we make the releases only to the staging area and not to the end user, yeah, so that customer can test the release. Okay. Okay, just give me 1 second. Just give me 1 second. I see that there is an agenda defined here, and I get what you are saying now. Just give me 1 sec. Okay. Now I get it. So you guys have already attended the previous webinars? So what I now get the confirmation is that this discussion about DevOps and these things are already covered, and now we need to cover more things, and for that we discussed on static code analysis and Ansible. Okay, I see many of you are saying no. Okay, then just give me 1 second. Okay, just give me 1 second. Let me confirm with SkillUpRight. Okay, guys, I am back. So I have been told that these all topics are covered in the previous webinar, and in this session, okay, I have very little visibility in what has been discussed with you and your L&D team, but now this session is set up for talking about SonarQube and Ansible. Okay, so I'm going to stick to that agenda. But nevertheless, we had a good basic discussion on DevOps. So, what I'm going to talk about is some specific concepts in DevOps, right? So, when we talk about DevOps, let me open the next page here. When we talk about DevOps, I mentioned that the term is DevOps because the development guys do some operational tasks, right? So for example, what could be operational tasks when we do DevOps? For example, there could be infrastructure provisioning, right? For example, you want some servers to set up your Jenkins, or to set up your uh, or setting up your software services. Then there could be infrastructure configuration, right? To configure the infrastructure as and when desired. Okay. Then there could be many other things, right? For example, monitoring. If you want to monitor the infrastructure, or you want to keep an eye on an application. Yeah. So these are some of the topics, some of the things that your development team may have to work on. So as you can see, these are purely infrastructure or operational topics. So the development team should be enabled to perform all these activities, right? So for infrastructure provisioning, there are some tools which can help the development team, or even traditional operations team as well, to provision the infrastructure during dynamic provisioning, like you want to deploy some cloud servers, or you want to deploy some managed services on demand. You can do those using the tools. You don't need to know the internal working of the infrastructure. How does it work? You just need a interface to get the infrastructure provisioned. Similarly, for infrastructure configuration, you have some tools. Yeah, for monitoring, you have some tools. So the development team can pick up those tools and start doing all the requirements for their project. So in today's discussion, we will talk about infrastructure configuration. If you have some servers, how do you configure them for your team without worrying about the low-lying infrastructure topics? Okay, so we are going to talk about Ansible. Yeah. Then another topic that we will cover is from the development side itself. We should be able to ensure that we are delivering good quality code by doing a static code analysis for our code base, analyzing our code base for any problems with how the code is written, how the code is being tested, and things like that. So we will do a static code analysis using SonarQube. Okay, so we are going to devote the next 1.5 hours or quarter to 1.25 hours on Ansible and SonarQube. All right, so let's talk about Ansible. Now, Ansible is a infrastructure configuration tool, also known as configuration management tool, or short form is CM tool, configuration management tool. You can also talk about these as server config management tools. Okay, so Ansible is a server config management tool, and in the brief 30 minutes that we have for this, we are going to understand how it works. Okay, and maybe I will show you some small demo also on that. So the idea is that you have many servers, multitude of servers, right? And you want to configure them as per your requirement. Maybe these 3 servers have to be set up as Jenkins masters, right? These 2 servers have to be set up as, or these 4 servers have to be set up as Jenkins nodes, right? You want to configure these servers like that. This server has to be set up as your Git server, right? So how do you configure them in such a way or at a scale that you configure them as per the requirements? So one thing that you can do is you can log into each server here and do required changes on the servers. For example, you can log into this server 1 and install Jenkins, install Java, set up everything, create initial user, uh, create some default jobs, and done. Now same thing you can repeat on server 2. Log in, install Java, install Jenkins, create default user, create default jobs, and done. Same for server 3. And you can see that it's not scalable. If you have to configure everything by hand, then it's a very daunting task, and repetitive, no value addition. Can we automate this? Okay, similarly here you have 4 Jenkins nodes. You have to configure them almost exactly in same way. You have to configure all of them. So wouldn't there be some automation available? So yes, there is some automation available, which is available in the form of configuration management tool. So this is how you do it. You have a master machine or a controlling machine which has Ansible installed on it. right? You have a machine which has Ansible installed on it, and then what you do is you define the state of your infrastructure that you want to configure, right? So you say that my server 1 should have these tools installed, my server 2 should have these tools installed, should have these users created, should have these services running, should have these configuration files. My server 3 should have these tools, these users, these services, these config, these ports opened, yeah, something like that. So you can specify the desire of the state of the infrastructure that you want, and you feed this desired, so it's desired state, so you feed this desire to Ansible, right? And what Ansible is going to do is it's going to analyze this desire here and use its technology to implement that desire into the actual configuration. So in server 1, when you feed this desired state to Ansible, it will realize that in server 1 this particular package is required, so it will enable that package here. Maybe it will install it, maybe it will download it, what it will do, however it will do, that is not our concern. We don't care how Ansible implements it, we just care about what we want. Similarly, Ansible can implement in server 2 the desires that we specified, and in server 3 the desires that we specified, right? So as a DevOps engineer, you will manage the desired state of your application or of your infrastructure, feed the desired state to Ansible, and then Ansible will implement the desired state to the individual servers here, right? So if the desired state for the server was for S3 is to have these particular configurations, those configurations will be made available on S3, right? Similarly, if S2 had these configurations as a desire, those will be made available on S3. And similarly, S1, if it has some configurations desired, it will be made available to S1. Right? So this is called as a server configuration management tool. You have many tools like this. For example, you have Ansible, you have Puppet, you have Chef, you have CF Engine, SaltStack, whatever. Many tools here. We are just using Ansible as an example here, right? So in Ansible, this desired state is called as playbook, right? So you write a playbook which contains the desired state of your infrastructure, and then you give it to Ansible core or Ansible engine, and then Ansible engine implements that desire on the infrastructure. So let's take a quick example of this, a quick demonstration to show you how it can work. Right? So just give me a sec. All right. So I'm going to create some servers on my AWS account. Okay, so on my AWS account, I'm going to create 3 servers, 3 machines. Yeah. And then we will see a quick demo for these 3 machines. So one of the machines will be master, right? And the other two machines will be host. Okay, so there are three machines that I have created. What I'm going to do is I will, on one machine, the Ansible master machine, I'll set up an Ansible engine, and the two other machines I will use as our deployment targets to show how our configurations can be applied. Yeah. So all my machines should be up and running. All right, at least the Ansible master is up and running. I'm going to connect to this machine. Hopefully, my command window is visible to you properly. Is the text size okay here? Maybe I'll zoom in a bit. All right. Okay, maybe I'll make it much bigger. I'm not sure what device you are using, but if you maximize the screen, it should be pretty clear. Okay, hopefully the letters are much better now. Okay, so this is an Ubuntu based machine. So I'll update my Ubuntu cache. So my screen is already maximized. Guys, from your end, please maximize the screen. Okay. Okay, done here. Now I'll say apt install Ansible. Yes. And this installs Ansible on my main machine. Cool. Right? If I run Ansible, I should get some output. Fantastic. Done. Okay. So here is another machine. Where is it? Where it go? Here. So here is my SkillUpRight machine host one. Let's connect to that as well. Connected, and host 2 as well. Now on host 1 and host 2, we can live with smaller text size. We don't want to see much details there. So yeah, hopefully that will be okay. And this is our, on the left hand side is our Ansible master. So what we are trying to do is we are trying to write our desired state file on this Ansible master and get our desired configurations on these nodes. Okay, first thing is that I need to enable passwordless SSH communication from this machine to this machine and this machine to this machine. So from master to host 1, master to host 2. Okay, so I'm going to generate SSH keys. Hopefully you guys already know what are SSH keys. Yeah. Otherwise, you can read about SSH and passwordless SSH. I'm going to copy over my public keys here. So what is the advantage? Well, now I can do a passwordless SSH to any of these machines. If I did this, yes, and I can log into that machine, right? Similarly, if I give SSH to this machine, accept the connection, 172 should be done. Oh, I did not log out from the previous machine. So if I do SSH and here, yes, and I'm logged in. Okay, all right. So this is how I can work with passwordless SSH to my machine from my master, right? Now let's write a state file. For example, on this 208 machine, I want to install um, I want to create a couple of users and create a couple of files. And on 172 machine here, I want to install some of the packages, right? So we'll see quickly how we can use Ansible to make those changes. So as a developer, I do not have any idea on uh, how to create users on target machines or how to manage some packages or files on the target machine. So as a DevOps engineer, I just want to do it via Ansible. So first of all, I'll tell Ansible about these machines that I want to manage. So I'm going to add this information to etc Ansible hosts. I'm logged in here. Log out. etc Ansible hosts. So this is a file which gives the Ansible tool information about which servers to manage. So this is a server that I need to manage, and this is the server that I need to manage. Okay, so I'll just update the host file, which is called as inventory, and then let me write some state file here. So as I said, I should write a state file which defines the desired state that I want to achieve on my target servers. So I will write a state file. I'll say this is a playbook. So I'll say uh, SkillUpRight underscore playbook dot YAML. I open the playbook here, and here I will define the state that I want each of these machines to be in. For example, on machine 208, I want uh, a user called demo to be available, right? So I say that I want to have this particular state here, manage machine 208. There is a name of the change that I want to make. Then on this machine, the change should be made, and these are the tasks that I want to run there. So that means I want to create or ensure user Alice exists in the machine, right? In the system, I would say. So what I'm doing is I'm now managing this 208 machine. Yeah. And first thing I'm doing is I'm going to ensure that the user Alice is available on this machine. I'm going to use a user module here. Now module are specific in Ansible, modules are small commands, external binaries, which are responsible for actually making the change on the target systems. So I'll say that I want to use this user module, and this user module should make whatever change I define here or state I define here on this particular host. Okay, so here I want to manage a user called Alice and ensure that the state of the user is present. So that means Alice user should be present on this machine. right? Then I want to do something else. I want to, let's say, uh, 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 ensure user demo exists with home directory as slash tmp, for example. Okay, so I'm going to use a user module. Very simple here. Name demo and state is present and home is slash tmp. Okay. Now, how do I write this? How do I remember all the syntax? Well, it all is documented. Here, if I say Ansible modules, I can look for user module. And here I can see the complete documentation about how I can manage users. Right, so this is the user module here. And yeah, so unfortunately, we do not have much time to talk about in these things in detail. So I am going to quickly show you around. Right, so slash tmp is going to be uh, the home directory for this user called demo. Okay, so this is what I want on machine 208. Then let's manage machine 172. Okay, so that means I want to manage this host, right? So what are the tasks I want to run on this machine? Well, let's say I want to ensure package finger is installed, right? So I'm going to use a module called apt, and in the app module I can say name is name of the package is finger and state is present. That means that package should be present, and also I want to update the cache, so I want to also run that apt update thing here. Okay, so I want to update the cache also. Similarly, I can say, well, name ensure package ntp, for example, is installed. Yeah, and again I will use apt, and I can say name of the package is ntp, and that's all. So I'm running two sets of tasks here. These are all called plays, right? So this is play one, this is play two. A play is nothing but a collection of tasks directed at certain hosts. So this is a play which says manage machine 102, and as part of this play, I am ensuring that package finger and package ntp are installed on these machines, on this machine. And as part of this play, I am ensuring that two users, Alice and demo, are present, and the demo user has home directory called slash tmp. Yeah, and let me create one more play, which is manage all machines, right? And then I can say that this play applies to all hosts. And what are the tasks that I want to run on this machine? Pretty simple. Let's say I want to manage a text file on all the machines. So I'm going to use a copy command, copy module, and I'll say that slash tmp slash file from ansible.txt should be created on all the hosts, and the content for that should be hello from SkillUpRight. Okay, there are three plays now. This last play applies on both the machines. So as you can see, I did not have to know how to create a user, how to install a package, how to create a file. I just wrote this desire here, and that desire will now be applied on these machines. Okay, I'll save it and I'll say Ansible playbook and playbook name which I want to apply. Right? Press enter here. Okay, there is a online number 4. Let's open this playbook. Let's see what could be wrong. Name, hosts, tasks. Okay, maybe, yeah, maybe we don't need this. Let's see if this gets rid of that error. Yeah, that was it. So that was not required. And now I'm running this playbook, and you can see now it is running a play machine, managing machine 208. So it has ensured that Alice exists on the system and user demo exists on the system. So if I go to 208 machine and I say ID Alice, I will see that Alice is created, and I say ID demo. I see that demo user is also created here. If I go into /etc/password, you can see Alice and demo have their entries here. Alice has /home/Alice as the home directory. Demo has /tmp as the home directory as I desired. Right? So my desire is now implemented here on the machine. And on 172, some changes are being made. For example, package finger was supposed to be present. So let's see. If I say finger, I get some output. So that means the finger package is now installed, right? And package NTP also should be installed. So service NTP status and NTP is also installed, right? So on machine 172, NTP was supposed to be installed and finger was supposed to be installed. Now on all the machines, I wanted to manage the text file. So if I go to /tmp here and I list down all the files, there is a file called file from ansible.txt, and it has the content hello from SkillUpRight, right? Same here. If I say /tmp/file from Ansible hello from SkillUpRight, it also created these two files on my target system. So this is the power of Ansible. The idea is that you don't need to know how to configure servers. You just define your desired state for the servers, and the desired state is achieved by implementing. Yeah. So this is a brief summary of Ansible. Is it possible to change the background? Yes, we can change the background. Is it better? So there was a typo in the YAML. That was the error. So no need to talk about that in detail, but it was just a typo. It was not a configuration error, just a typo here. What are the packages, Finger and NTP? We don't need to worry about those as well. These packages may do something, may not do something. As an example, if you wanted to install something, that's how you will do it. Okay. All right. So this is how you use Ansible to make changes to your system or to manage the configuration of your servers. Now here I just showed you example of 2 servers. You can have 100 servers, and you can just write the state file and ensure that the state is achieved on 100 servers. Okay. All right. So that's done. Now let's talk about Ansible. Okay. So the Ansible, no, not Ansible, SonarQube. So let's talk about SonarQube. Let's go back here. So we understood how we can manage our infrastructure configuration using Ansible, and then we see how we can check the quality of our code using SonarQube. Okay, so this is what we do. SonarQube is a static code analysis tool. That means SonarQube tests, checks the quality of the code that you have written. It does not check the correctness or accuracy of the product that you are writing. It does not perform any tests. It just checks the quality of the code that you are writing. So is your code very complex? Is your code written in a readable way? Is your code following certain guidelines? Is your code compliant to certain standards defined? Right? Are you dividing by zero? Are you leaving enough comments? So all those checks are performed by a static analysis code or static code analysis tool, and the tool that we are going to talk about is SonarQube. Okay, so it works like this. You have a machine here, and that machine contains your code. Okay, this machine contains your code, so it can be in any language, but the thing is it contains your code, right? So what you do is you do a static code analysis on this code. You want to see what is the quality of the code that you have written. So in SonarQube you have something called as a sonar scanner. Sonar scanner is a small binary which runs on the local machine, and it takes the source code as the input and then generates a report. It generates a report. Then what happens to this report? Well, this report goes and it's parsed and analyzed on the central SonarQube server. Okay, so this report is then sent to the SonarQube server. The SonarQube server will then analyze it and then display some observations. Display some observations about your code and the quality of the code. Okay, so there are two components involved. One is a SonarQube server and one is SonarQube scanner. So now what I'm going to do is, of these two machines, three machines that I had created, one of the machine I will use as SonarQube server. So for example, this machine, this machine I'm going to use as SonarQube server. Okay, and then we will use this SonarQube server to analyze and display the report, and on this machine, which is the white background machine, we will perform the SonarQube analysis. Okay. Now, first thing that we require is a source code. First thing that we require is a source code. So I'm going to get a source code for us. A second. So for example, there is a source code which is available for us. Yeah. So I'm going to clone that source code here like this. So this is a simple Java application. Maybe I should find a better application here. Sample Java. Just give me 1 second. Yeah, this one is much better. I'm going to use this particular application here. So it's a sample Java project. Okay. And if I get into this project here, I will see that there are pom.xml, pmd.xml, and then the source file, and then the test file. If I go to source file, source directory, then you will see a lot of code base here. So there is this Java file here. Yeah, you can see this particular Java file has all the Java code implementation um, and things like that. So let's say this is our source code. Okay, this is our source code, and in the source code, we want to analyze the quality of the code that is written. Right. First thing is that we need to download SonarQube scanner. So let's go to SonarQube's website. I'll search for SonarQube scanner, and here you have the download links. So for example, there is a download for Linux. I'm going to copy this link, and I will say that in my root directory here, download SonarQube zip. It is downloading here, and I will say unzip Sonar scanner. Unzip is not found. I will install unzip quickly. Here you go. I'm unzipping SonarQube scanner, and if I check the current directories, I have this Sonar scanner directory here. In the Sonar scanner directory, I will have a folder called bin, and this bin directory, I have Sonar scanner binary. So that's all we need. We need the Sonar scanner binary here. Okay. Anyways, let's go to our home directory and let's go to sample application. And what I'm going to do is I'm going to say run my Sonar scanner on this particular code base. So from my home directory, from Sonar scanner, bin Sonar scanner, run the Sonar scanner here. So it fails. Sonar scanner fails here in the first instance because it says it cannot reach the SonarQube server. So Sonar scanner, once it runs, it actually requires connectivity to the SonarQube server. Now, right now, we do not have the SonarQube server. So let's get it up. So I will use this machine here. This could be our SonarQube server machine. I'll change the settings to make the text size a bit larger. Maybe this is okay. And what I'm going to do is I will use Docker to run SonarQube server. Okay. So hopefully you guys are aware of Docker, but if you are not, that is perfectly fine. No need to worry about what Docker is doing here. What I'm just doing is running SonarQube application. That's all. So for that, I need to install Docker here. Maybe this machine is running out of resources. It feels like that. So if I go to my 172 machine, not this one, then this one, because I'm not getting any output here. Machine is not responding. Yeah, machine is not responding. So I'm going to quickly fix it. This is the one, this is the machine. And for this machine, I'm going to stop the instance and I will add some more resources to it. Right, I'll say instance settings. I'm still not getting. So let the system stop here, or I start a new instance then. Just give me a sec, yeah. So that machine was low powered. Let me get a fairly decently powered machine here. This machine we are not using anymore. This as well. So this is going to be our SonarQube server. Let it come up. And this machine also we will power off. Okay, machine should be coming up. SonarQube server. Yes, SonarQube server is up here. Hopefully I get quick access to it. Yes, so here we are going to install SonarQube pretty quickly. First is we need to install Docker. And done. You can see here, if I go to this URL and go to 49153, I will get SonarQube. Okay, so SonarQube is still booting up, but yeah, 49153 is where SonarQube can be reached. Okay, so I will get back to my service here, and here when I ran Sonar Scanner, I got an error that SonarQube server cannot be reached. So it tries to reach SonarQube server at this particular address. So we should specify where our SonarQube server is. Okay, so in this here I will say Sonar Scanner hyphen b sonar.host. My SonarQube host is at this particular URL. Right, this is my SonarQube URL. Here you go. Okay, so good. Press enter. Sonar host equal to. So now, just give me a sec. should be Sonar host. Let's go to the Sonar scanner documentation where it is. Yes, and Sonar host URL. So we have to say Sonar host URL. All right, my bad here. I'll say sonar.host.url is this. Now you will see it tries to connect to that SonarQube URL, and this time the error is something else. It says not authorized. So I need to authenticate to the SonarQube server also. Now let's go to our SonarQube server. Let's log in here. And now I'm going to create a secret key or token for myself so that I can authenticate. So I'll say my token like this. So token is an API key kind of thing. So now I will say that here you can see in the documentation now it will say if you want to authenticate, then there should be sonar.login. Okay, sonar.login should be passed. So I'm going to do that. So I'll say authenticate -d sonar.login is this. Authenticate with this token. Let's enter now. All right, now it goes a bit further. It gets more information that this is our SonarQube server ID here. More details are getting, but it says you must define the mandatory property for Sonar project key. Okay, what is it? I will tell you later, but I will now add one more thing. Sonar dot project key, and let's call it as sample code base. Okay, let's keep everything as small case sample. And now analysis is running. Some error happened. Your project contains .java files. Please provide compiled classes with sonar.java binaries. Okay, so let's take some other project. Yeah. Uh, so with Java, it's a bit uh, complex. We have to first compile Java. Yeah. So we don't want to compile Java. So I will just get a Python based project. So this is Python based project here, right? And you have a lot of data here. So for example, you have .py and all that stuff. Let's analyze this one. I'm going to run Sonar scanner, press enter. All the parameters are specified, the URL and authentication and all that. And you can see execution is success. And here it says that you can access the report at this URL. So I'm going to browse to this URL now. And here is my project analysis, right? So if I go to SonarQube homepage, I will see this project, and this project analysis report comes here. So there is one security hotspot in this project. right? And if you want, we can fix it. If you don't want, it's okay. So if I click on one here, it will show me where is the hotspot. So security hotspot is here, and here it says clear text protocols such as FTP, Telnet, or non-secure HTTP lack encryption. We are using HTTP here. So SonarQube will say you are using HTTP. You should, I think, move to HTTPS. Okay, so this is a security hotspot, right? So yeah, this is how it is done, and some help, like how can you fix it. So you can use either SSH or HTTPS instead of HTTP and things like that. Okay, we can add some more problems in the code, and then it can also be captured. So but let's talk about SonarQube here. So what we have done is we analyzed our source code, it generated a report, and it displayed the report on the SonarQube server. Okay, now the report here is stored for each project in its own project name. So sample code base is the project name. This is the name which we gave when we ran this analysis, right? So if you remember the command here, I clear the screen, we gave the project key is sample code base. This is what we want to call our project, sample code base. So here is the project key, that is sample code base. So this is a sample code base project which is created now. Okay, now if I go to this page here, it says overall code has this particular problem. So why does SonarQube thinks that these are problems? Well, because SonarQube checks our code base against certain rules. Those rules should be followed, or those rules should be honored when writing a code base, right? So here are all the rules which are used in SonarQube to check your code quality. And you can see here there are a lot of rules, 2470 rules to be exact. And then there are rules for individual projects. So you have 603 rules for Java, 400 rules for C sharp. For Python we have 172 rules. Okay, so if I click on this, I can see all the rules for Python. So it says less than and equal to, less than and greater than should not be used to test inequality. Equal to plus should not be used instead of plus equal to. So these are all the rules. Break and continue statements should not be used outside a loop, for example, right? So these are some of the rules which are available, which your code base is checked against, right? But here there are 170 rules, 172 rules for Python. Maybe in your project you don't want to check all the rules, right? You don't want to check all the rules. In that case, what you will do? Well, if you go to your project and not here, but if you go to project settings, you have something called as quality profile. Okay, quality profile is nothing but the list of rules which are being checked for a project. Okay, so if I go to quality profile here on the top, I can see the list of rules that are available in quality profiles. So for Python, there is a quality profile called SonarWay. It's built-in profile that it comes by default. We cannot change it, so this list is static. So if I click on SonarWay, I can see that 134 rules are enabled and 38 rules, Python rules, are disabled. So out of 172 Python rules, 138 are enabled and 38 are disabled. That means any project, when it is analyzed, and if it is using SonarWay quality profile, it will only going to use 134 rules. It will not check all 172 rules. So you can specify a list of rules like this, which you can check your project against. So you may add more rules here, you can remove rules here, and then check your project against those rules only. So you can increase or decrease the scope of test that you want to do. Okay. Now, when your project is analyzed, left hand side you see something called as past, right? What does it pass? It passes a quality gate. What is a quality gate? Quality gate is a threshold of the quality status of your project, where you define what is the acceptable quality of my project. If I meet that quality, I should be able to make a release. Otherwise, I should not be able to make a release. My stakeholders will scold me because the quality of my code is not good. That threshold is defined in quality gate. Now, if I go on top here, we have quality gates here, and you can see there is a default quality gate, which is SonarWay, and it has defined some threshold. So if coverage is less than 80%, then quality gate should fail. If the reliability rating is less than A, then quality gating should fail. And you can add more rules here. For example, if total number of bugs is more than 0, then quality gate should fail. If total number of issues found in this is more than 10 or 15, then also it should fail. Right? So you can specify what is the gate or what is the criteria for marking your project as successful. Okay, you can also customize it by changing it. So the built-in profiles and built-in quality gates cannot be modified. You can create a new quality gate. Let's say I want to create a quality gate called SkillUpRight, and then here I will specify my threshold. For example, add a condition. I'll say on overall code, on if there are more than 5 bugs, then the quality gate will fail. Okay, if there are more than, I can add more configurations here, right? So if I go to quality gates, I see 2 quality gates now, SonarWay and SkillUpRight. And if I go to project, sample code based project, if I go to quality gate here, I see that it uses SonarWay quality gate, right? But now I want to use SkillUpRight quality gate, so I will assign that quality gate as a governing factor for our application and click on save. Right? So this is a brief overview on SonarQube, how you can use SonarQube with your code. All right. Now I am open for questions. So there are some questions. Can we perform dynamic code analysis through Sonar? No. SonarQube is static code analysis tool only. Can the quality gate be customized? Yes, I showed you that. Can we create a rule as well? You can create rules as well. Yes, you can create customized rules. But there needs to be a learning done for that. So you can create customized rules. You need to do uh, uh, do a little bit of learning. What is cognitive complexity? Okay, so there are two types of complexity. There is cognitive, and then there is I forget the technical name for that. Uh, uh, okay, so there is complexity, then there is cognitive complexity. Okay, now cognitive complexity actually talks about how hard the code is to understand. A code can have complexity of 1, which is the most simplest complexity, but still it can be very hard to understand if the if the statements are quite complex in themselves. Okay, so cognitive complexity is kind of a subjective matter. where it all depends from person to person. But yeah, that talks about that. Cognitive complexity is about how complex the code is to understand. Can we create Sonar Scanner and SonarQube server in VM config? Yes, you can. Can we use DevOps for database patch deployment? Well, databases are quite complex. Yeah, databases require you to always have a plan for rollback and things like that. So I wouldn't say databases are good candidates for DevOps deployments. Yes, that is cyclomatic. The other complexity is cyclomatic. You are right. Thank you. Is SonarQube replacement for check styles, PMD, and find bugs? Yes, kind of. So instead of using SonarQube or check styles, PMDs, and find bugs, you can have all of those combined and have them in SonarQube. So SonarQube is now kind of a standard tool to be used for checking your code quality. Any other tool instead of SonarQube? Yes, there are some language specific tools like for C and C++, there is Polyspace, PC-lint, and things like that. So you can explore those also. SonarQube is more of a general purpose tool. What is the criteria to identify new code and old code? So new code will be the code that was not existing before in the SonarQube repository and it has just come in. Do we need a separate VM to configure SonarQube in Azure DevOps? You can use Sonar Cloud also, which is the cloud instance of SonarQube. You can also run SonarQube in an existing VM. Should be okay. Anything should be fine. How can we add users and groups to SonarQube? So it's pretty easy. You can go to administration and manage users. So you can add users and groups to SonarQube just like that. Okay. Which which model is best among these three? So I assume you are talking about waterfall, agile, and DevOps. So it all depends on your use case. There is no best model. It depends on what you want. DevOps sounds quite interesting, but it requires a lot of dedication and hard work to achieve it. But it has great results as well. So you can go for that. Waterfall is a pretty standard tested methodology. You can go for that. Generally, agile is the one people prefer, and they pick up some components of DevOps, but continue to be with agile. Yeah. Okay. So that's all from my end. Thank you for your time. Thank you for the interesting questions. And I will see you around some other time later. Right. Thank you and take care. Be safe. All the best for your career. Thank you. Bye bye.